All right. Hello. I'm so glad to see that many people interested in native script. My name is Erjan Gavalji. I work with Progress as a senior software engineer, software architect, I'm sorry. I've been with the software business for more than 15 years, and I still enjoy writing software. We will talk today about native script. By the way, how many of you have already tried that product? All right. Not that many, not as many, but this gives me the unique opportunity to introduce it to the product. And I hope that by this time next year, this entire audience will have native script as the preferred mobile platform for building your own mobile applications. This session will will dive deeper into how native script as a product is built. Native script is an open source product. And with that, I hope that I will use native script as an example of how an open source product is built. And I hope that it will help you. It will give you a head start, shall you decide you want to jumpstart into the adventure of building and maintaining an open source application. The session will start with defining the need of native script. We will see the engineering side of building that product. We will check how what building blocks is the product comprised of, and we will see the development processes that the team applies. In the second part of this session, of this presentation, we will see the things beyond the engineering. I will call them the business side of native script. We will see how the product gets popularized and adopted across the world. We will see how the product gets financed, because after all, it's a business. And we will see how the community gets nurtured. So first, let's check, let's answer the question of why native script. Native script, to answer that, we will we'll see some history, go back to history. In the beginning, there was iPhone. Mr. Jobs introduced that in 2007. iPhone had provided the ability to build applications with iOS as a platform and Objective-C as the development language for it. Many companies saw the opportunity of the mobile, and they started gathering teams to build mobile applications. Soon after that, Google introduced Android. Android started becoming popular because the devices were cheaper and because some people saw Apple as too elitist, and they cheered Android as a platform. So with this popularization of Android as a platform, the companies companies had to build teams around it as a platform, and they had to hire teams to code in Java. Microsoft saw that they were missing the train of the future, and mobile is the future. And they created Windows Mobile, and companies had to build teams and to educate people to code either in C# or Visual Basic.NET or Visual C++.NET, and use and learn WinRT as a platform and build for that platform as well. With that, it was a huge challenge to have 3 teams with 3 languages and additionally because every platform vendor had their own guidelines of styling your application, building the UI, and building the interaction of the users. You had to, product managers had to maintain, had to keep 3 teams in sync with all these applications. With that, it was, though building native apps was really gave the benefit of having a fast application, and following these guidelines became natural. Learning the platforms, the underlying APIs was hard. It was hard to find talent, or if you wanted to build your own team, to educate your people, it got hard. So a solution had to be found. And 2 years later, a company named Nitobi had a eureka moment, and they found out that there is a common element in every platform, every mobile platform. It was the browser. They noticed that, in 2009 they presented that you can have a browser component, the so-called web view, in an application shell, and you could use JavaScript and CSS, the DOM elements and CSS to build applications. To access the native components, such as the accelerometer, such as the gyroscope or the Bluetooth interface, you could build native plugins which gave the ability to address and use these components. So with that, they solved two problems. The problem of the talent that was not available, and the problem of the multiple code bases. You could write a single application which a single team of developers could maintain. There are, as we know, the majority of the developers in the world are web developers, and there are a lot of front-end developers available out there that you can hire to style the application for you. The thing is that to follow the guidelines the platform vendors introduced, you had to apply tons of CSS. You had to still have branches in your code, and with that, the applications became slow and their rendering was bad, was terrible. And again, you had branches in the code, although they were a little bit hidden underneath. There were no 3 applications, but you still had branches. And then enter NativeScript. NativeScript is a solution that gets the best of both worlds. It makes native components available to the developers without the hassle of the DOM element. There is of the DOM structure. There is XML for arranging your application, but the parser is really fast, and there is no harm done to the performance of the application. It is easy to learn because it's pure JavaScript, or you can use TypeScript or Babel that can get transpiled to JavaScript, but in essence, it's still JavaScript. With that, there is large developer base. If you have seen, last year there was survey done by Stack Overflow where JavaScript developers were the most developers in the world. The other good thing about NativeScript is that it provides, it has CSS parsing, and you can style your elements with familiar CSS syntax. The framework automatically discovers native classes available in the targeted platform, so you can address any class and any class that is available in the underlying platform. So that makes it, as these are done dynamically and automatically, unless there are drastic changes done by the platform vendor, you could, it is most likely that your application will build and run shall Apple or Google release a new version of their platform. The NativeScript team calls this zero-day support, and we're very proud of that. The other thing, some of you might already started to think that with NativeScript you would have to write a lot of if statements and branch your code. This is almost true. There is a specific layer in NativeScript that is called the cross-platform modules, which is a common abstraction above the underlying elements. And basically, unless you have you want to have something nitty-gritty in your application, you could use the common elements that are available through this abstraction. You could use the button, a label, layout, or anything, and you will get your application just running without addressing iOS or Android code. The architecture of NativeScript is that it has a JavaScript engine embedded in it. That JavaScript engine is modified just a little bit. It's V8 for Android or JavaScript Core for iOS. There is a proof of concept, by the way, for demonstrating how JavaScript Core can be used to build Windows, universal Windows platform applications. You just write JavaScript code. The framework builds metadata for you automatically so that the classes that are inside the platform are available for you in the JavaScript context, and NativeScript takes care of marshalling the data between your JavaScript layer, your JavaScript code, and the platform itself. There is one thing to remember. When you walk out of this room, from an engineering perspective, there is one thing to remember, and it is that there is no web view. Unlike hybrid applications, NativeScript has no wrapping web view, and your code is pure JavaScript, and there is XML there is no DOM inside. Of course, if you want to have HTML rendered, you can instantiate a web view and place it inside your layout. However, this is upon desire. If you do it only if you want to. So there is no web view, and this is one of the distinguishing things for NativeScript. All right, let's move on to the project and team organization of NativeScript. There are several important projects. There is the command line interface, which is the front-facing application. This is the application that you install. It's an NPM application. You install it globally, and you use it to create your projects, to add plugins or runtimes to them. Plugins are something similar to the hybrid applications that you can code something in a native environment, so that and to get a more performant or something complex as a functionality. So you use the command line interface to add such plugins or runtimes to your application. You use the command line interface to build the application, to pack it, or even to deploy it. You use the command line interface to debug your application as well. Then there are the cross-platform modules that I already talked about. There are the runtimes projects. There are two projects. One of them is iOS runtime, and the other is Android runtime, and the proof of concept that I mentioned already. The runtimes are blocks, the blocks that have the JavaScript engine inside them. They have it modified. The runtime takes care of automatically generating the metadata for you, so that your application has the native elements available for you to use and build the application. So there is the other important projects are the integration test suite. These are really important. There are more than 800 tests there. Besides the unit tests, these are the tests that verify the integration between the cross-platform modules and the one runtime and the other runtime. There is the documentation project that is, of course, always important. There is the examples application, which is the other front-facing application each of you can download and install right now from either Google Play or the App Store. The examples application gives any potential customers the ability to play with NativeScript and check its performance and the features that it provides. And there are a lot more applications, a lot more projects available at GitHub. There are plugins, demo applications, experiments. There is even a graveyard for old and abandoned projects already. As a source control management system, the team chose Git. We store our repositories at GitHub. We have our code written in the cross-platform modules in TypeScript. We have the runtimes written in Objective-C. We have the iOS runtime written in Objective-C and the Android runtime written in Java. There is C++ code when needed to address some specific elements in the runtimes. And there are Markdown. There is Markdown as I'm sorry. There is Markdown to support the documentation. The branching model. Most of the repositories have a long-running master branch and use topic branches and pull requests to integrate the changes, to add the changes to the main project. We call this master branch a semi-stable branch because when a pull request gets accepted, although the unit tests might pass, the integration tests, which are slow, have not yet passed, and it is possible that that the integration gets broken. With that, there is a release branch created regularly when a release approaches. This happens once in 6 weeks, and the integration tests, as well as a lot of manual tests, get started when a release happens, and once know the structure of the CLI and be able to fix or address issues there. Hence, there is not a team for that. Sync with that many teams is a challenge. However, with great people, make it possible to align and build the things, communicate clearly, and make the things right. So let's move on to the development processes. Continuous integration is done on internal machines and on public machines. We would prefer to have everything available publicly on Travis or anything else as a built infrastructure. However, there are no public offerings or free offerings or cheap enough offerings available that could handle the load that the team, the native script as a product requires. As you will see later, there are a lot of tests running, probably 500,000 or 1 million tests running every day. So with that, after calculations, the team decided that we will have an internal structure which is built with via Jenkins CI server. No, the internal infrastructure is utilizing Jenkins CI server, and it is automated. It's built is automated via Chef, Ansible, or Chocolatey. There are 12 internal build machines running 4 operating system versions, several 2 iOS versions, 3 iOS versions, 1 Windows version, and 1 Linux. I think it was Ubuntu 14.04. So that makes it 5 operating system versions. There are 10 mobile OS versions, operating system versions, 3 iOS versions, and 7 Android versions. And there are 800 plus build jobs running to run all the possible tests and all the possible combinations between these devices and operating systems and emulators, simulators. There are unit tests in each project, as I said, and there are the integration tests. The test runs get triggered either nightly or upon commit and pull request. We, the team, take care of the security really much, and for that we utilize the feature of the plugin, of the pull request plugin of Jenkins, where we can whitelist the crew members, and upon approval of admins, the pull requests of a community member can get verified. Here are some vanity stats. You can do the calculation yourselves. There are, although these should not be directly multiplied, there are more than 1,200 unit tests. There are more than 800 integration tests run on 2 platforms, on 20 devices, on more than 20 devices, and not counting the emulators and simulators. And these happen on more than 500 runs daily. The next project is the documentation. It's built with Markdown and translated to HTML with JQ. JQ is a Ruby plugin, if you know that. It has several types of articles. The topic articles, which are more than 180 articles written and maintained manually. There are API reference articles that are generated automatically from the code base. There are the SDK examples, which are again generated, extracted from a fully capable running application. And there are a lot of more articles that get fetched from external repositories. The documentation, as I said, uses a specific branching model. The master branch, which contains changes, the team writes changes that will appear in the next release. And there is the production branch that accumulates fixes that will appear right away. There is, once you commit something to the production branch, in less than 15 minutes, it gets published live. It gets deployed automatically. And if you commit to the master branch, there is an internal server where the change appears so that the team can check the results of their efforts. The Travis CI environment and the Jenkins environment are used to automatically pack and deploy next packages. Next packages are somewhat stable packages that are actually previews of the next version that we will release. Customers can use these packages to check to check if their applications will run fine with the next features and the changes that the team have made, and they can communicate with the team if everything is okay for the upcoming release. Although the team would love to have everything in Travis CI, there is a limitation, for example, for the iOS runtime, that iOS runtime, its build and tests take more than an hour and a half, and Travis CI has a limitation of 50 minutes runtime. So that's why we need to have an internal deployment for that. Releases. As I said, there are 6 weeks release cycle. Of course, that's not set in stone. For example, this is a secret. Please don't tell anybody. For example, we will delay the release that should have happened next week. Sometimes there are features that are bigger and they need some more time to get implemented properly. When necessary, the team introduces hotfix packages and delivers them to the public. And here is another secret. These hotfixes are perceived as the official releases are perceived as not as stable as we want to, and the team decided that starting the next release, we will output RC release candidate packages first, which will get tested and verified in addition to the next packages, they will get deployed and verified by the community, and upon that, after verification that everything is okay, then an actual release will happen. And now let's see how the NativeScript team decides on the priority of the features and which features to implement. Here is the first set of features, the first decision of making which features to make is the essential features and the essential provides to the community so that they choose you instead of the competition. I selected 3 of the most popular features of NativeScript. These are the direct access to native components, the automatic binding and metadata generation, and the 0-day support that happens therefore. The next thing that you can use to prioritize your applications is how the feature will help your product get more popular. The NativeScript team chose Angular 2 as Angular 2 integration because we saw Angular 2 as an opportunity to have NativeScript perceived as the de facto mobile story of NativeScript, of Angular 2, I'm sorry. With that, we invested a lot the last year to build the integration with Angular 2 and to have it seamless. And even going further, developing the story further, we are right now building a joint story between NativeScript and Kendo UI. We provide a common API so that people can not only, developers and companies can not only have the same code base for the platforms, for the mobile platforms, but they can have the same code for having both mobile and web code and web applications. The next thing, the next driver of your features is really important, not only for open source companies, but for companies at all. It should be. This is the desires and the needs of the community. NativeScript are listening actively to the community. It is not needed, by the way, to directly implement what the community wants. It is, you should instead think of, listen to the community, listen to the problems they have, and then try to provide solutions that will help them achieve what they need. With that, for example, the NativeScript team found out that customers need development, need integration with familiar dev tools, and that's why we decided to use the Web Inspector and the Chrome dev tools for debugging the application and checking what's going on under the hood with your application. We decided that we should implement Visual Studio Code integration. Although nobody asked for that, we found out, we discovered that the getting started experience with NativeScript was hard, and the integration with Visual Studio Code made the learning curve better than it was before. WebStorm, there is an integration with WebStorm as well, which is the most popular. According to some surveys we did, WebStorm is one of the most popular IDEs for building mobile applications. The great thing here is that WebStorm integration was built by the community themselves, not a WebStorm employee, not a Progress employee, but somebody, a volunteer, decided to implement that. And when you see that, you as a team just get happy. The other features driven by the community were layouts and styling via CSS and CSS animations. Flexbox is familiar UI building framework, and we decided to implement that. There are internationalization and localization built by the community themselves again, and web workers were are a feature that was long waited and long wanted from the community, and we're releasing this with the next release. Let's wrap up the engineering side of the story. We saw the team and project organization that matched, but not as a rule of thumb. We saw the development processes and the feature prioritization, the methods to prioritize features. And let's move to beyond engineering, where we will see how the product gets popularized and financed. First of all, as engineers, we always tend to neglect the importance of marketing, but believe me, that matters, even for an open source product. Your product never gets popular by itself. We're just not that creative. Even Steve Jobs did a lot of marketing. Actually, there are a lot of people say that the machine behind Apple is that they are really good at marketing. So do not ignore these. DataScript team uses Twitter ads and Google AdWords to make the product more popular. With that, it is good to track the success of the results of your efforts. We use the statistics of npmjs.com to check the CLI downloads. These tell us how many people use the product. You can see the chart that the usage is growing. Then we use Google Analytics as well to monitor the documentation site and the website and the core website of NativeScript visits. These are growing as well, and we're pretty happy with these. Then we track how the community, how well do we do with the community. We check the blog visits, we check the Twitter and tweets and followers on Twitter, newsletter subscribers, Slack channel subscribers. These are growing as well, and which tells us that we're doing well. If there is something that is not growing, then we should address immediately. We should act immediately. And let's see the financing. Although financing is something really, really important because this is a business, I left it to this moment because, well, forgive me, I'm an engineer. An important thing is that, after all, this is a business and a company. Somebody has invested in it and expects returns. So how can you get returns from an open source product? There are various methods. You can even check Wikipedia for open source products. There are a lot of entries there for monetizing out of any open source product. The NativeScript team chose several. The first one is building value-added services around the core product. And with that, the Progress as a company have invested into building a team that creates a UI for NativeScript package, which is a set of nice, complex elements, components that you can use in your application, and they're behaving really, really nice. These are sold. These are offered for purchase by customers. And then there is the other product Progress is building. It's the app builder. This is de facto a graphical UI over the command line interface. It allows you to create and manage projects with a graphical interface for customers who are not that comfortable with command lines. The other option to monetize from an open source product is integrating other services, integrating your product to other services to increase their value, and thus get an indirect revenue from, for your product. Such a product for Progress is the Digital Factory. It was announced several days ago. Digital Factory is a large product that targets any size of companies, from small companies to large, really large enterprises, where it aims to solidify their digital story. It provides the ability to, it provides companies with the ability to have all the content and any applications that manage purchases or anything from within one single application. With that, NativeScript is the de facto, no, it's not the de facto, it's the mobile offering of digital factory. And then there is the third way of monetizing from an open source product. It's familiar since the beginning of open source products. A lot of companies use it. It's offering premium support for companies that want to have this guaranteed. So the next, and now we get to the next really important part of building an open source product, especially. It's growing the community. And this is the second thing that I want you to remember which is really important from a non-engineering view of the product, that the community is your most important asset. The pillars of success for NativeScript in growing the community were, of course, making a product that matters, then communicate, listen to the customer problems, and make the details crystal clear when talking with them, so that you get the get the right thing to solve, not to delve into a side story. Then encourage contribution. Make sure that the customer understands your drives for asking them to make a change or another. Make sure that the customer knows that you love their contribution and you only want to make a service to the rest of the community really useful. And then the other thing is to manage the channels to maintain focus. There are lots of channels, support channels and communication channels out there. Pick some and stick to them, with watching from time to time if you need to switch from a channel to another. In the NativeScript team, every single person is involved in communicating with the community. There are a team, a special team, developer relations. These guys are, their main responsibility is talking and actively contributing to the community. They're visiting conferences, meetups, and they're blogging, creating videos, and anything you can imagine to contribute to the community growth. There are the support engineers who address immediate questions from the community. There are the product managers who ask the community for their opinion and build the priority lists of the features. There are the engineering team members who try to help with any question that gets deeper in the code that cannot be answered by the other team members. And then NativeScript has already grown to such an extent that we have community experts who are helping the other community members with their questions or problems. There are various support channels. As I said already, NativeScript team have chosen GitHub to gather issues and to communicate on them. We use the progress support system to handle the support requests of paying customers. We use a Slack channel where everybody is talking and trying to help to the questions, and the community, you can see the community experts there in action. These guys are fantastic. In the beginning, we had chosen Google Groups as a channel to gather feedback and something like forums, which could be used as a persistent medium for content, but later we decided to switch to Stack Overflow, and right now we're using it instead. There are different presence channels you as a contributor to an open source product can choose to use. There are conferences you can attend to, meetups, user groups, blogs, Twitter and Facebook groups, YouTube channels for media. We, our NativeScript team, are proud to have held our own conference in Boston a month ago. There were various speakers there, developer relation members, engineers, community members. This was the place where experts meet customers, and this is a good place where you can gather ideas from the community, and you can meet community members face to face and make sure that these guys see you face to face. When you see somebody face to face and you know that he's using your product, you just this boosts your motivation a lot, and it's the same for the community member. They know that there are people working with them. There are some vanity stats. There are more than 350 plugins available at npm.js, which are created by the community members. There are pull requests that happen in the four repositories, the core modules repository, the documentation, and the runtimes repositories. There are blog posts by the community, conference attendance where community experts and community members get to our booth and help us with addressing questions. There are videos and tutorials created by the video conference. And when you do it right, you get this. Thank you. Thank you. Well, let's wrap up the engineering side, the non-engineering side of NativeScript. We saw how we can increase the awareness and adoption of an open source product. We saw how we can build, that we should build services aggressively to monetize from the product, and that the community is your most important asset and how to nurture it. As a summary of the entire presentation, we started with the purpose of NativeScript. We saw the team and project structure and as well as the development processes, and we saw how what are the approaches of the NativeScript team to prioritize the features they will build. And then we saw the popularization, monetization, and the community growth that are non-engineering side of the NativeScript story. Please don't hesitate to contact us either in the Slack channel, GitHub, Stack Overflow, or Twitter. We'll be more than glad to address any questions you might have. And remember, there is no web view, and the community is your most important asset. Thank you.
Okay, let's see. Working. Okay. Wow. All right. I have a good one for you.
All right.
What's the difference between NativeScript and Apache Cordova in Xamarin?
What's the difference between NativeScript and Apache Cordova? The difference is that Apache Cordova uses the JavaScript engine that is inside the underlying platform, and there is a browser element wrapping up the application. There is HTML, there is the DOM, and the styling gets done. You build your applications by styling DOM elements. In NativeScript, the JavaScript engine is embedded in your application and in the NativeScript runtime, and there is no DOM. There is a simple XML parsing engine, and you address directly the UI elements are the native elements, and you get the styling that the platform vendor has provided you.
So if you don't have a DOM, how you build the UI?
You just create a layout container and then plug anything you want to plug in it, a button or a layout or another layout, cascading layouts, or a text field or anything. These are just pure native components available here, no DOM.
Does NativeScript support full CSS3 feature set?
Well, a tricky question. Not all of them. We still have only several. I'm not sure which ones exactly. We have the borders support. We have rounded corners. I think we have, of course, fonts and font styles implemented. A full list is out there somewhere. Just write me an email and I'll make sure to point the right place. And of course, as being open source, we really appreciate any pull requests and any commits you might have. We will be glad to help you have this for us.
Okay, there's one more here. Can you make a dissection of Hello World app running on, let's say, Android device? Where's the browser web view?
There is no browser web view in the default application. There is no browser in a default Hello World application. The default Hello World application has MVVM implementation and a button demonstrating that after 42, the magic number, after 42 clicks, a text element, a label, text gets changed. There is no browser there. If you want to, you can have an HTML view, an HTML and a browser element, but this is similar to your computer. You can have an HTML file somewhere in the hard disk of your computer, and you can load it in the browser. And that's it. That's exactly how the browser, the web view component, runs inside NativeScript. There is no web view. There is just the pure your JavaScript code that gets translated and directed to the underlying platform, and the runtime instantiates the right classes for you. Shall you write, when you write that you want, when you instantiate a new button, the runtime knows that there is that you are targeting Android right now. It instantiates a widget, Java Java widget. I'm not sure about the exact namespace there, but it instantiates an Android. It translates it to new Android button that gets the runtime marshals that code to converts that code to instantiate to the instantiation of an actual Java button, and that's what it displays.
All right. Any questions from the audience? There's one over there.
Do you have an API?
Wait. We have a microphone.
I can still go.
Yes, but you won't be recorded on the video.
Do you have an API for data persistence?
Do we have, the question was, do we have an API for data persistence? Not for the time being. We are working on several different solutions, actually, and unfortunately, we still haven't decided on which one we should use. Just if you're more interested, just send me an email and I'll get you introduced more on these.
Okay, we have one.
Yeah. Do you have some kind of inside information from Google or Apple? What will be the next feature in the next operating system?
All right. The question was if we, the NativeScript team, have an insider information from Apple or Google on what their next features will be. No. We do not have any information besides when, while working with the Android team, with the Angular 2 team in Google, we had, and all this communication was public. We had regular meetings once a week with their team members where we synchronized on how the things are going and the problems we have. They had suggestions on how to fix one thing or another, but we didn't know when the Angular 2 release date would be. We didn't know that.
All right. I think there are no more questions. So thank you very much.
Thank you. Thank you.